Hello students, I hope all of you are doing well. So in this video we will be discussing a NEET NLM PYQs. In this friction questions are also included. So NLM and friction, both of the chapters we will discuss. So let us start. So the first question that is given to us is, it says a football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. Okay, let us draw the vector diagram. So football player is moving southward. This I'm showing south and then eastwards. Vector diagram. So V and V moving with same speed. It says the force that acts on the player while turning is along northward, along northeast, along southwest, along eastward. That means they are asking us the direction of force. When this player when he turned from south to east, during this time, in which direction your force was acting? Because when he changed the direction, velocity will change. Velocity will change when acceleration is there. Acceleration will be there when some force is there. So that force direction they are asking. How do we calculate force? What is our force? Force is basically mass into acceleration. So whatever is the direction of force will be same as acceleration. That means whatever is the direction of acceleration, same direction will be of force also. So let us see direction of acceleration. What is our acceleration? Acceleration is delta V by delta T. Acceleration is delta V by delta T, right? Change in velocity. So over here, what is the change in velocity happening? So this is your V final and this is your V initial, and a magnitude wise speed is same, but the direction has changed, so velocity also changes. So if we can find out direction of change of velocity, not of velocity, direction of change of velocity, we will get direction of acceleration. If we get direction of acceleration, that is the direction of force. Let us see delta V. What is delta V? Delta V is V final minus V initial. V final minus V initial. This is our V final towards eastward. This is our V initial downward. V final minus V initial. So we have to find out direction of this. We will use your parallelogram law of vector addition to find out the direction. How? This is V final, this is V initial. What is our minus of V initial? If I have to draw minus of V initial, it will come, basically minus V initial is, we will turn it by 180 degrees. So this is your minus of V initial. I hope this point is okay. V initial was downward, minus V initial is upward. Now this is V initial, this is minus V initial. We need to add them vectorially. So parallelogram law, if we consider it, this is our this, right? Parallelogram law. So over here along the diagonal, we will have our resultant of V final minus V initial. This is what we have got it. This is the direction of delta V. This is direction of delta V, this is direction of acceleration, and this is the direction of force. What direction it is coming? This is your northeast. This is coming your, this direction we have got it, northeast, right? So our answer will be over here, second option. Second option is our correct answer. Let's look at the next question. Yeah. So our next question we have is, calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is 0.15. So mu s value, coefficient of static friction is 0.15 given. They are asking us maximum acceleration. Understand this question. So what is given to you is some car. They have mentioned that a car is moving with some acceleration A. What can be this maximum acceleration A such that a box which is a body which is kept inside does not move? A box or a body which is kept inside does not move ahead. Now if we take a look at the situation of this body, what is happening over here? Let's understand this, or let us take a look at this block with reference to the car itself, right? Let's suppose we are observing this with reference to the car. Now car is a accelerating body. That means it is your non-inertial frame. Now whenever we observe an object with respect to a non-inertial frame, we bring pseudo force. Pseudo force in which direction? Pseudo force will act in backward direction. Let's say that the body's mass is m, so pseudo force in backward direction, opposite to the observer. So if you observe with respect to car is moving ahead, so on the body your pseudo force will act in backward direction, m into a. Pseudo force magnitude is m into a, and obviously it is moving ahead and it is stationary. Which force is keeping the body along with the car, which is helping the body to move along with the car? It is your static friction. Static friction will be acting over here, force static, right? Friction static. How much is the maximum value of acceleration they can apply, or what is the maximum acceleration of car? So for that we know that this MA, maximum acceleration, will be balanced by your static friction. Now what is our maximum value of static friction? Maximum value of static friction is mu s into n. Mu s into n. This is our maximum value of static friction, right? And n value, how much it will be? N will be mg down, normal will be up. So we can write down mu s into mg. So for maximum acceleration, your MA should be equals to maximum static friction, which we also term as limiting friction, which is equals to mu s mg. Let us equate them. So we get over here MA is equals to mu s mg. M and M cancels out. So A is mu s. How much we got? Given 0.15 into 10. So it comes out 1.5 meter per second square. So how much is the maximum acceleration of car possible? 1.5 meter per second square. Which option? Option number 2 is our correct answer. Okay. Our next question, which is your 22 question, NEET 22 question, it says, in the diagram shown, the normal force acting between 2 kg and 1 kg is, right? This is what is given to us. I have drawn the figure. It is there for you people also. Now, they are asking us normal force between them. Normal. So, what normal will be acting? This 2 kg will be applying normal on 1 kg and 1 kg will apply normal on 2 kg, right? It will be like this. I hope you all agree with this. Normal will be, they will apply action reaction normal on each other. We have to find out this magnitude. How do we calculate? Now, if you notice carefully, 60 Newton is acting downward, downward, that is up the incline, and upside, from upside your 80 Newton is acting down the incline, right? Apart from these two external forces, your component of mg will also be acting. 3g sine 30, 2g sine 30, 1g sine 30, right? All the component of mg sine 30, because blocks are kept on the incline. Blocks are kept on incline, so your mg sine 30 component will also be acting. Now, over here, so first of all, to calculate normal, if we can find out the acceleration of these blocks, first we will find out the acceleration of blocks. Once we get acceleration of the blocks, we can apply F net equals to ma on any one of them and calculate our normal. How do we calculate acceleration? So for acceleration, we will consider all these blocks to be in a part of single system. And that means why we can consider them as system. I have discussed this in our revision video also. Whenever different blocks in a system are moving as with same acceleration, whenever different bodies are moving with same acceleration, we can consider them as a single system. And therefore, I'll redraw it as a single system. This is 3, 2, 1. So basically, I'll take it as 6 kg single block. Why I am able to do this? Because we know that they are constrained to move with same acceleration, whether downward or upward, we'll check that, but they will be moving with same acceleration. That's why I have considered them as single block, right? A single system. So 6 kg. Now let us see it. Over here, upward will be 60, downward is your 18, and over here 6g sine 30. 6g sine 30 will be acting. Let's see, 6g sine 30, that implies 6g into 1 by 2, that is your 30. So downward, finally what we are getting? Upward is your 60 and downward you are having 30 plus 18, downward force is your 48. Which side the system, that means all these blocks, which side they will be moving? Up the incline, because the net force upward is 60 Newton and net force downward is 48 Newton. So they will be having upward acceleration. What will be the acceleration? Acceleration we can write as F net by M. Acceleration F net, how much it is? 60 minus 48, that will be your 12 divided by total mass of the system, which is your 6. So we are getting acceleration as 2 meter per second square. This is the acceleration of each block. This is the acceleration of each block in upward direction, 2 meter per second square. Now we want to calculate normal. On any one block, we can apply the force equation. Let's say that I am applying it on this. On 1 kg block, I am applying the force equation. Let's draw our FBD for 1 kg. I'm doing over here. This is a 1 kg block. What all forces will be acting on it? Obviously, normal from 2 kg will be in upside because normal is pushing always. And then you will have 1g sine 30. 1g sine 30. That will be your 10 into 1 by 2. This is your 5. And 18 is acting downside, right? Down the incline. Let's write down. So this is your 5. Now, let's write for your 1 kg. F net is equals to ma. What all we are getting? It is having an upward acceleration of 2 meter per second square. Is it visible to you guys? Yes. So n minus 5 minus 18 is equals to 1 into acceleration is 2. N is equals to 23 plus 2, which is 25 Newton. So this is our answer, right? Option number 1. Option number 1 is our answer, right? Let's move ahead. Okay, next question says a ball of mass 0.15 kg, a ball of mass 0.15 kg is dropped from a height 10 meters, strikes the ground and rebounds to the same height, right? The magnitude of impulse imparted to the ball is fine. So, situation given to us is that from a height of 10 meter, a ball is falling and it strikes over here and then again rebounds at the same height, right? This is what is given. They are asking us the impulse imparted. What is our impulse? Impulse, we write it as, impulse is basically change in momentum. Impulse is basically your change in momentum. So in this process, how much is the change in momentum happening? So while this, during the impact, what is the change in momentum that is taking place? Let us see, I'm drawing over here. When it will be released, when the ball will be released, it will come down. Just before hitting the ground, it will gain some velocity, which I am calling as V initial. It will strike the ground, rebound, and then it will gain some velocity. That means it will have some velocity. That's why it's going up. And this is I am calling as V final. And then it reaches to the same height, right? So V initial and V final. Now one thing you can see very clearly that it is coming down 10 meter and it is going up 10 meter. If it is going up 10 meter, that means there is no loss of energy over here. If there is no loss of energy, that means this V final speed will be same only. If this is V, this will also be V only. I hope this point I am using this theoretically directly from our concept of energy. Because over here it strike over here and it rebounds again to the same height. If it is rebounding again to the same height, that implies there is no loss of energy over here. No loss of energy, it's a perfectly elastic collision. No loss of energy, that means over here speed is V, so again your kinetic energy should be same. That implies your speed should be V. Velocity will change, but speed will be V only. Now let us calculate our V value. How much is our V value? If a particle is dropped from height h, how much is the speed? Root over 2gh. This is what is our speed. So V is equals to root 2g into h. 100, 200, root 200, that means it will come out to be 10 root 2. How much is our speed coming? 10 root 2. This is V initial magnitude, that means when it is falling down, and after rebounding also it will be, speed will be 10 root 2 only. Why I am taking 10 root 2? Because it is reaching to the same height, that's why speed will be 10 root 2 only, but obviously direction will change. So let us see delta P. What can I write? V final minus V initial. V final minus V initial. V final, it is in upward direction. How much it is? 10 root 2 minus of, this will come, m will also come because momentum will be m into delta V. M into delta V. So m into V final is 10 root 2. V initial. V initial, that means before hitting the ground it was downward. So minus of minus 10 root 2. Fine. Mass is given to us 0.15, that is 15 by 100 into 10 root 2 plus 10 root 2, it will be your 20 root 2. What are we getting over here? 1 time, 5 time, 3 times, right? 3 root 2. So our momentum, that is change in momentum, which is equals to your impulse, comes out to be 3 root 2. 3 into 1.41. 3 into 1.41, when we will do it, our answer will come out to be 4.2. Right? This will be our answer. Which option it is given to us? Option number 2. Option number 2 is our correct answer, right? Let's move ahead. Okay. Next, a pulley block system is given to you. On one side 4 kg, on other side 6 kg. Very standard problem. Acceleration they are asking. What do we know? Acceleration result for pulley block system. Acceleration is given as m2 minus m1g by m1 plus m2, right? M2 is the heavier one. So we will get it 6 minus 4 g by 6 plus 4, that is 10. So A value comes out 2g by 10, which is g by 5. So acceleration is g by 5. They are asking us in terms of g, so it will be g by 5. Which option it is? Option number 4, right? Yeah. So our question given to us is a body of mass m kept on a rough horizontal surface. Okay. Coefficient of friction is mu. A horizontal force is applied to the body, but it does not move. Body is not moving, that implies static friction will be acting, right? The resultant of normal and the frictional force acting on the object is given by F, right? Let us draw the situation. A block is kept on the horizontal surface. Let's say a block of mass m is kept, right? Let us draw all the forces on it. Let's draw the FBD. Normal will be upward, mg will be downward, and external force is acting on it. Some force is acting, but it does not move. It does not move, that means the static friction, it will be opposite to the force, है ना? So this is your force static which is acting. Resultant of normal and friction. Resultant of normal and friction, if we see, this is our vector diagram, this is F given to us. How much will be the resultant? F will be root over normal square plus friction static square. Now the thing is that this friction static, as we know that static friction is self-adjusting in nature. Friction static value can be vary from 0 till your mu mg. In this case it will be mu mg, है ना? Friction static maximum value we write as mu n, which is in this case mu mg, because normal is equals to mg over here. Fine. So in this range your static friction can vary. So friction static will be less than or equals to your mu mg. Therefore this force, the resultant, what can we write it? This resultant minimum value will be equals to normal. When your no external force is acting, that means your friction static will be 0. So minimum will be 0, normal. But if we have to write the result, it will be less than or equals to normal square. Normal is equals to mg, that means mg square plus your maximum value of static, because we are writing less than or equals to, which is mu mg square. If we simplify this, we get F should be less than or equals to, mg comes common, and out of the root over 1 plus mu square. This will be our answer, right? Option is option number C, right? Let's move ahead. Yeah. Question is given to us. A particle moving with velocity v is acted by 3 forces shown by the vector triangle PQR. The velocity of particle is. So this is your P, this is your Q, and this is your R, right? This is what is given to us. What will be the velocity? What will happen to velocity? If you notice carefully, the resultant of P and R will be opposite to Q, something like this. If I draw it for you, it will be something like this. The resultant of P and R, resultant of P and R will be this way, but our Q is opposite coming over here. That means they are forming a closed triangle. This P, Q, R are forming a closed triangle. That implies F net of all these will be 0. F net of all these will be 0. F net is 0. That implies your acceleration 0. If acceleration is 0, velocity remains constant. Velocity remains constant, right? Let's move ahead. Next, we have a theoretical question. Let us see which of the following statement is incorrect. 4 statements are given to us. Let us see. Rolling friction is smaller than sliding friction. This is a correct statement. Second, limiting value of static friction is directly proportional to normal reaction. Your limiting friction. Friction limiting is given as mu s into n. So friction limiting is proportional to normal. It's a correct statement. Third, it says friction force opposes relative motion. This is the definition of friction. So it's a correct statement. Last, it says coefficient of sliding friction has dimension of length. That means L. and a dimension of length meter, it will be your L. Let us see. So friction we know is given as mu into N. Friction is mu into N. Mu will be what? Mu will be friction by normal. Friction is a force, normal is a force. Newton by Newton, it will cancel out. That means your coefficient of friction, coefficient of sliding friction, it is a unitless quantity. It's a unitless quantity. If it's a unitless quantity, it will not have any dimension, right? That implies your statement 4 is incorrect. Yeah. Next question. A block of mass m placed on a smooth inclined wedge ABC of inclination theta as shown in figure. The wedge is given an acceleration a towards the right. The relation between a and theta for the block to remain stationary on the wedges. Okay, let us see. They are asking us relation between a and theta such that this block remains stationary on the wedge. Now this question we will do with the concept of pseudo force. How? Let's say that we observe the block with respect to the wedge itself. That means the observer is, let's assume that is on the wedge and he is looking at the block. Because it is stationary with respect to wedge, so acceleration is 0. Let us write down. Let us draw first of all your FBD of the block. FBD of the block with respect to this observer. This observer is on the wedge. That means it is an accelerated frame. So with respect to this observer, there will be a pseudo force will be coming. Pseudo force opposite to the acceleration. Acceleration is forward, right side. So pseudo force will be left side. How much is magnitude of pseudo force? M into A, right? And over here, what other forces will be acting on it? Other forces, normal will come over here. Then your mg sine theta and mg cos theta, right? Now they are saying that with respect to the wedge it is stationary. So with respect to this observer it is stationary, so we can balance the forces. Let us see. This is your theta. If this is theta, this angle will also be theta. This ma, the pseudo force component, if we do it up the incline, it will come out to be ma cos theta, and perpendicular to incline it will be ma sin theta, right? It is stationary, that implies forces should be balanced. Along the incline you can do it. Along the incline if we do it, ma cos theta should be equals to mg sin theta, right? Balancing the forces, because with respect to the wedge it is in equilibrium. So ma cos theta is equals to this, cancel out, a value comes out, g sin theta by cos theta, that implies g tan theta, right? Acceleration is g tan theta. Which option do we have? Option number 3 is our correct answer. Okay, so the last question that we have for this video is, it says two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. You people also have your question. Now I have drawn for my purpose. Let us see. The whole system is suspended by a massless spring as shown in figure. So massless spring is also there. The magnitude of acceleration of A and B immediately after the string is cut are respectively. So what happens is that this is cut. Your string is cut, immediately they are asking us the acceleration. Now over here we should understand this thing. What is the nature of a string and what is the nature of a spring when a cut is made, है ना? So whenever a cut is made, the tension becomes 0 immediately. Whereas in a spring, the spring force, how much is spring force? K into x. That kx does not become 0 immediately. Kx, that means the force will not become 0 immediately. Just after the action, that means cutting off the string, your spring force will remain. Spring force changes gradually, whereas this changes gradually, right? So just after cutting, whatever was the kx, that means whatever was the spring force acting on this 3m, that will remain, and tension becomes immediately 0 as soon as we cut it, right? So this is the concept that we need to keep in mind, then we will do it. So initially when it was not cut, let's suppose when the two blocks were hanging with the help of the string and spring, what will be the situation? If we draw all the forces, mg will be downward, tension will be upward, on this T will be downward, and 3 mg will also be acting, and your force of spring will be in upward direction. Fine. Now on block B, if we balance the forces initially before they are in equilibrium, so initially tension is equals to mg. This is from block B. From block A we can write down force of spring is equals to T plus mg. Force of spring, I hope all of you can see, T is also downward, 3 mg is also downward. So force of spring which is upward will be T plus 3 mg, which comes out tension is equals to mg. So force of spring is 4 mg. This is what we got it, right? Now see the interesting thing. So as you cut it, as you cut this, what will happen? This goes away. This goes away. There is no string now. There is tension is 0. So this on the block B, only one force is acting, which is your mg. And due to this, mg is equals to mass of B is m into a. That implies acceleration of B will be g downward. Acceleration of B is g downward. Fine. On block A, what all forces are acting? Over here this T was acting, tension which became 0 immediately, but 3 mg will be downward, and spring force do not become 0 immediately. Gradually spring force changes. So spring force we got it as 4 mg. 4 mg is in upward direction. Let us see. So for block A, what do we get it? 4 mg upward and 3 mg downward, right? Net force is in upward direction. Let us write down the equation. F net is equals to ma, 4 mg minus 3 mg, which is your mg, and I hope it is okay. 4 mg minus 3 mg, mg is equals to mass of this, mass of block A is 3m. 3m into a, mm cancel out, acceleration comes out to be g by 3 in upward direction. So which option it is? G by 3 for A and G for B. Although direction they have not asked, if they would have asked it, G by 3 for A it will be upward, for B, B will be having a free fall, G downward. Okay. So with this we have completed all our questions. I hope you found the video helpful. If you found it helpful, do consider to press the like button and subscribe to the channel. Thank you very much. Bye bye.